Hi, once again, everyone. It's Professor Sebastian. Back to our statistics class notes. We're on page 70 in section 5.3. And we are trying to work our way towards a rule for the word and, right? Remember we combine events like A and B. So we need to understand a little bit about how to do that. Probability and the word and. So let's examine closer our formula for calculating conditional probabilities. So recall that if we have the probability of A, given that we know B occurred, probability of A given B, that's equal to the probability of A and B divided by the probability of B, because we reduce the sample space to just B. So if we know the events are independent, then we have the following. The probability of A given B is just the probability of A. So if I substitute that probability of A in for probability of A given B into our conditional probability formula, that goes right here on the left-hand side. Okay, and then if I just do a little bit of algebra, multiply both sides by probability of B, I can see that the probability of A and B is equal to the probability of A times the probability of B, which is what I have here. So for independent events, I just multiply probabilities if I have an and situation. If A and B are independent, right? There's no knowledge afforded to me about the probability of A given that I know B occurred. Okay, so probability of A and B are independent, then you just multiply their probabilities, probability of A times probability of B. That's called the multiplication rule. Now for dependent events, right, where the probability of A given B cannot be replaced with the probability of A like I did up here, then the probability of A and B is equal to the probability of A given that we know B occurred times the probability of B. That's just rearranging this formula by bringing probability of B over here to the left-hand side. Multiplying both sides by probability of B, in other words. Okay, most of the time we're going to be talking about independent events when we use this multiplication rule, especially in this class since this is not a course on probability and probability rules. So for example, let's say we want to talk about the gender of babies. Let's assume that we know, or suppose we know, that 49.2% of babies born in the US are girls. And let's say a couple has 2 children. So I'm going to assume that babies' genders are independent. Okay, whether a baby is a girl or a boy, just because a couple had a girl the first time doesn't mean they're more likely or less likely to have a girl the second time, etc. That's what independent means. So let's let B equal a boy, G equal a girl. So the probability of having a girl is 0.492 according to this information up here. That means the probability of having a boy, because that's the complement of having a girl, would be 1 minus 0.492, which is 0.508. So let's determine the probability that both children are boys. That means we want to determine the probability that we have a boy and another boy. That would just be the probability of the boy times the probability of the boy, because we're going to say that it doesn't matter knowing we had a boy the first time than whether we have a boy the second time. So they're independent events. You just multiply their probabilities. So 0.508 times 0.508 comes out to be 0.258 or 25.8%. Now let's say we want the probability that the first is a boy and the second is a girl. So we want the probability of a boy and girl. Again, independent events means we could just multiply their probability. So probability of boy times probability of girl, 0.508 times 0.492 equals 0.250 or 25.0%.